All right, let's talk about a term you've probably been hearing everywhere lately, LLM ops. Today, we're going to crack open what that really means and look at how developers are going from just cool AI demos to building products you can actually rely on. You see this chart? It just perfectly captures the AI explosion we're living through. For years, the actual capability of these models, that's the solid line, was growing pretty quietly, way ahead of the public hype. Then, boom, ChatGPT happens, and the hype, that dotted line, goes completely vertical. But, for the people who are actually building with this new power, this creates a whole new world of challenges. It's one thing to make a demo that wows people. It's a completely different ballgame to build a real product. And that's exactly what we're going to focus on. We're not going to get lost in all the technical weeds. Instead, we're zeroing in on that critical 20% of large language model operations, the stuff that's going to give you 80% of your results. This is the new rulebook for building with AI. So what exactly is LLM Ops? Well, it stands for Large Language Model Operations. You can really think of it as the entire discipline built around one central question. How do we take one of these mind-blowing AI models and turn it into a reliable, predictable product that people can actually use? It's the essential bridge from a cool prototype to a real-world application. So what does that journey from a model to a finished product actually look like? Well, a pretty standard workflow has started to emerge, and it all begins with a really fundamental shift in how we think about building AI. Let's walk through it. Before we even get to the steps, you have to grasp this huge mindset shift. The AI expert Andrej Karpathy just nailed it when he said this. See, the old way was to train a model from scratch for one very specific task. It's quickly becoming a thing of the past. The new way is to start with these massive pre-trained base models and then just adapt them. Pretty much nobody is out there training a competitor to GPT-4 from a blank slate anymore. And that new reality gives us these 4 core steps. First, you select a base model. Second, you adapt it for your specific task. Third, and this is the big one, you evaluate if your changes actually made things better. And finally, you deploy it and keep an eye on it. Sounds simple enough, right? Well, the devil is definitely in the details, especially in step 3. So, your first big choice is the base model, and you've basically got 2 main paths. You can go with proprietary models, from places like OpenAI or Anthropic that you access through an API. They're incredibly powerful and super easy to get started with, but you don't have a ton of control. Or you can use open source models from hubs like Hugging Face. This gives you way more flexibility and control, but it often takes more work to get them to that peak performance. It's that classic trade-off between raw power and fine-grained control. Okay, once you've picked your model, it's time to adapt it. And again, you've got 2 main tools in your belt. The first is prompt engineering, which is really the art and science of being a word wizard, crafting the perfect input to get the exact output you want. The other path is fine-tuning, where you're basically sending the base model to grad school. You continue its training, but on a smaller, super specialized set of data to make it an expert in your specific area. Right, so you've picked a model, you've adapted it, seems like you're on your way. But this next step, evaluation, this is, without a doubt, the single biggest bottleneck in all of LLM Ops. Getting this right is what separates the projects that succeed from the prototypes that just never see the light of day. It really all comes down to one simple but incredibly hard question. How do you actually know if your new prompt or your fine-tuned model is any better than the last one? How do you scientifically measure good? And here's the problem. Our old toolbox is, it's basically obsolete. In traditional machine learning, we had these nice, clean metrics like accuracy. A prediction was either right or wrong. But LLMs, they generate human language. It's messy. How do you assign a number to creativity or to politeness? How do you mathematically score a model for hallucinating, when it just confidently makes stuff up? The short answer is you can't, not with the old tools. And this brings us right to the heart of modern LLM ops. This is that critical 20% that's going to drive 80% of your success. To solve this whole evaluation mess, the developer community has come up with some incredibly clever new ways to measure performance. The most powerful solution is this brilliant concept called LLM as a judge. The core idea is kind of genius, really. It's simple. If these models are so good at understanding human language, why don't we just use a really powerful LLM, like a GPT-4, to evaluate the output of the model we're trying to test? You just give the judge LLM a grading rubric in plain English and ask it to score the response. A fantastic example of this in action is a framework called geval. It's this really clever 2-step move. First, you ask a powerful model like GPT-4 to generate its own step-by-step checklist for a quality you care about, like, is this summary coherent? Then, you hand that same checklist back to the model, along with the text you want to evaluate, and it spits out a score. And what's amazing is that the results line up incredibly well with what a human judge would say. Let's make this really concrete. A super popular way to build LLM apps today is called a RAG system. That stands for Retrieval Augmented Generation. All it really means is the model first retrieves some relevant info from a knowledge base before it answers a question. For these systems, there are 3 absolutely essential metrics. Faithfulness, which checks if the answer sticks to the facts or hallucinates. Answer relevancy, to see if it actually, answered the user's question. And contextual recall, to check if it found all the right information in the first place. So let's double-click on that first one, faithfulness. Here's how you can measure it using that LLM as a judge method. Step 1. An LLM goes through the generated answer and pulls out every single factual claim it makes. Step 2. For each one of those claims, the LLM checks if it's actually supported by the original source text. And step 3, your final score is just the ratio of supported claims to the total number of claims. It's a really elegant and, best of all, automated way to measure hallucinations. So when you put this all together, this new ability to do sophisticated automated evaluation, it just changes the entire game. It creates a whole new set of rules for AI development that look very, very different from what we were doing just a few years ago. And you can see that shift crystal clear when you compare LLM ops to traditional ML ops. The focus used to be on training custom models. Now it's all about adapting huge pre-trained ones. Experimentation used to be about hyperparameter tuning. Now it's about prompt engineering. Your biggest cost is no longer training, it's inference, the cost of every single API call. And finally, latency. How fast you get a response is now a massive concern for the user experience. So, the most crucial point, the one thing you should take away from all this, is simple. Mastering evaluation is the single most important skill in modern AI development. It is the engine that drives all progress. It's how you know you're actually getting better. It is that 20% of the work that will absolutely define your success. And this leaves us with a pretty fascinating question to think about for the future. As these models keep getting exponentially more powerful, more nuanced, will our ability to measure them, our very understanding of what good even means, be able to keep up? Well, that remains to be seen. Thanks for watching.